let's talk about the cycle of imaginary numbers. We learned the other day that the imaginary number I is equal to the square root of -1, which made things like the square root of 4 equal to 2i, where the square root of -12 can break down into 2i root 3. Well, today I'm going to talk about the cycle of 4 in imaginary numbers. So I know that I is equal to I. When I have I times I, which is I squared, that's equal to -1. When I have I times I cubed, that's equal to -1. And I to the 4th is equal to 1. So when I'm looking for I to the 54th power, I know that every time I have I to the 4th, those are going to equal 1. But I'm not going to take the time to write that how many there are. So what I'm going to do is I'm going to figure out how many 4s are in 54. And I know that, so literally what I'm doing is I'm taking 4 and dividing it into 54. And all I need is the remainder. Okay, I know 4 goes into 50, it goes into 5 ones with a remainder of 1. It goes into 14 3 times with a remainder of 2. When I have that remainder, this tells me that I squared, so I have all these 1s because of I to the 4th, 13 times, but I'm also going to have 1 I squared, which I know is equal to -1. So I know this answer is going to be 1 times 1 times 1, 13 times -1, so my answer is just -1. So I just tell my students, hey, go to where the remainder is. That remainder was at 2. Go to the second one, I squared, and your answer will be that, -1. So let's try some more. What if I have I to the 81st? Well, I know 4 times 20, which it doesn't matter what it is going to give me 80. And I have 1 remainder. And so the answer is just going to be I. If they're looking for the square root of -1, we can answer like that because we know that I is equal to the square root of -1. But typically they're talking about like this. All right, one more example. We had some fun ones in Delta Math that were like 3i squared minus 4i to the 10th plus 8i cubed. And what we had to do is break down all of these. I know I squared is equal to -1, so I'm going to put that there. I know I to the 10th, 4 goes into 10 to get me to 8. So I have a remainder of 2. So guess what? This is another I squared, which is equal to -1. And I know I cubed is equal to, a negative I, so I have to put that negative in front of the 8. So I know this is -3 plus 4 minus 8i. Well, -3 plus 4 is 1 minus 8i. So that's just a different way of adding like terms. Notice when you have an I, you can add another I to it, just like any typical Algebra 1 scenario. So great job in the cycle of imaginary numbers. Good job.